when we start looking at this first example, so we're going to look to first plot our point. So plot A, B, and C, because we got to plot something before we can start. So go ahead on your graph and plot A, B, and C. And this time we're using our center of dilation point P at 0, 0. So we can plot that just like we did in 6-4. So plot the 3 points, and then it tells us our center of dilation is 0, 0. If we do this just like we did the ones in 6-4, we're doing it by a scale factor of 2, so that means our k is 2. If we were to go and do our slope, from P to A we go up 2 over 1. So for A, if we have a slope of 2 over 1 but we're doubling it, what is our new slope? 4 over 2. So if I go up 4 over 2, I'm going to get my new A. What's the ordered pair for that? If we went up 4 over 2. 2, 4. So then let's do the same thing for B. B has a slope of up 1 over 4. If we double that, we get 2 over 8. So up 2 over 8, that'll be our new B. What's the ordered pair for that? For our new B prime? 8, 2. And then lastly we have C. C currently has a slope of up 4 over 3. And when we double it, we're going to get up 8 over 6. So from P, if we count up 8 over 6, we'll get our C prime. And what's the ordered pair for C prime? 6, 8. Again, we can check our work by making sure that our points all line up. So our center of dilation A and A prime line up. Center of dilation C and C prime line up. Center of dilation B and B prime all line up. So if we look at the original points for A, B, and C and the dilated by 2 points, do you notice anything? Looking at the original points and our new points after we dilated by 2. Every number is multiplied by 2. So what you can say for what do you notice? The points were doubled or were multiplied by 2. Okay, that's something special that happens only when your center of dilation is at 0, 0. Okay, so let's predict what we think our new ordered pairs would be. So here we have, again, 3 ordered pairs. We have 4, 2. So we'll call that A. 6, 4. B. And 2, 8. C. So here's our starting shape. Oh, way off on that one. If we're going to do a dilation of 1/2, what do you think our new ordered pairs are going to be? If again our center of dilation is at 0, 0. So 2, 1. What do you think B is going to be? 3, 2. Can I ask you how you're getting these numbers? You're multiplying each one by 1/2, which is dividing by 2. Okay, what about C? 1/4. So now let's actually go and do it and see if our prediction was right. So if we go back to our slope, from P to A, we go up 2 over 4. Well, what's half of up 2? Up 1. What's half of over 4?
2.
What's that ordered pair? 2, 1. So far, so good. Okay, now we're going to go do our slope from P to B. That's up 4 over 6. Well, what's half of up 4?
2.
And what's half of over 6?
3.
So there's our new B. What's the ordered pair?
2, 3.
3, 2.
Oh.
But yes. Okay, and then lastly, go to C. We go up 8 over 2. What's half of up 8?
4.
What's half of over 2?
1.
C prime. What's our ordered pair?
1.
1, 4. So did our guess match up with our dilated figure? Yes. And that's something that should happen. Again, because we're coming from 0, 0, we are going to have this this idea that we can take whatever our ordered pairs are and just multiply it by the scale factor to get the new ordered pair. So if you flip this over, we're going to do just that. We're going to create our new figure using what's called a dilation rule. So how we did our transformations back in, oh gosh, I don't even remember what unit it was. Unit 3 or 4, I don't remember. Earlier this year, how we did our transformations and we said if we're translating right, we add 1 to x. Okay, same idea, except this time with dilations, that's what multiplying means. Multiplying means we're either growing it or shrinking it. So this right here is our scale factor k. So this is asking us to double each term or each ordered pair. So what I need to do is figure out what's my starting ordered pair for each one. So A has a starting ordered pair of 0, 0. B is at 2, 4. C is at 4, 4. And D is at 5, 0. So if we're going to double everything, what would our new A be? It would stay 0, 0 because 0 times 2 is still 0. What about B? If we're going to double everything. 4, 8. Okay, what about C? If we're doubling everything. 8, 8. And lastly, what about D? 10, 0. So you can plot those and you should be able to connect the dots to get a twice as big dilated figure.
Do you have to plot them?
If it says to, yeah. It's here it says create the dilation. And then below it has another question for us to look at. If we compare these two figures, what would you say is true about CD? So CD, this line here, and this line here. What do you think is true about those two segments? They're parallel. Okay, we do know that CD is going to be twice as big. That's part of what a dilation means. But they're also going to be parallel. How could we show that mathematically? That two lines are parallel.
Slope.
It's slope. Okay, parallel you would show with slope. So we could go ahead and take our ordered pairs and do y1 minus y2 over x1 minus x2. And we get 4 over -1, which is -4. Do the same thing with C prime, D prime. 8 minus 0 over 10 minus 2. No, I'm sorry, it should be 8. That's wrong. 8 minus 0 over 8 minus 10. And that would give us 8 over negative 2, which is 4 over negative 1, which is negative 4. So they have the same slope, so that would be how we mathematically justify it. Okay, so let's look at the one right next to it, where it wants us to graph and label each figure with a dilation of 5 halves. So we're going to assume that we have a dilation around 0. I know it doesn't say that. With our center of dilation is equal to 0, or at 0, 0. So what are we going to multiply here? What would our rule be? We're going to take x, y, and what would we multiply everything by? What do you think we multiply by? So like here we multiplied by 2. What would we multiply on this one?
5 over 2.
5 over 2. So we're going to multiply everything by 5 over 2. 5 over 2x, 5 over 2y. So this would be what we call our rule. So now, let's go and apply it. What's 0 times 5 over 2? 0. And what's 0 times 5 over 2? 0. Okay, so let's go to a one that actually has numbers. 2 times 5 over 2. 2 times 5 over 2. What does that equal? Well, the 2's will cross out, and we're left with 5. And then what about 4 times 5 over 2? 2 and 4 can reduce, and we're left with 10. So we'd have the ordered pair 5, 10. And we can go through and do this with each ordered pair. So try on your own G and F. Let's see if you guys can multiply by 5 over 2. What'd you guys get for F? 15.5. Good. So then you'd be able to plot these to get your new figure that's been dilated about 0, 0. Okay, so what I want you guys to do right now is to look at worksheet 5. We're not going to do the last 2 examples. So I want you guys to look at worksheet 5. So here we're doing a little bit of the same thing we did on worksheet 4. We're going to first determine if it's enlarging or shrinking as we dilate about 0, 0. And then we're going to actually draw the new figure. So here it's saying we have a dilation of 2. Is that an enlargement or a shrink? Enlargement. So then what we can do over here to the side is figure out what is, let's see, we can start with M. So I'm going to just highlight my origin because sometimes on these pictures it's hard to tell. So my ordered pair for M is negative 1, negative 1. So if I apply the dilation to it, what's my new ordered pair? Negative 2, negative 2. Because we're doubling. So we can just multiply each of these by 2. Let's see, Q. Yes, sir?
Would it be possible if we're able to do the calculations in our head?
I need to see work. Okay, so if we have Q, -1 and 2, what would be our new ordered pair? -2, 4. So we can go ahead and plot that. So what I'm doing right here is I'm creating a mapping of ordered pairs, a lot like what we did back with transformations when we did rigid motion. So when you do these, I need to see this mapping so I know that, so I can see what you were trying to do. So for B, we have 0, 2. So what would be our doubling point? 0, 4. And then lastly, we have point I. Point I is currently at 1, 1. So where would our new point be? 2, 2. So after you say enlargement, you're going to create your mapping by just multiplying each ordered pair by whatever the scale factor is to get your new shape. Okay, but I just want to make sure you guys remember this only can happen if 0, 0 is our center of dilation. If it's not 0, 0, you have to do it like we did in 6, 4. Okay, so what you're going to do on 1 through 4 is what we just did here on 1. And then when you get to number 5, so go ahead and scooch down to number 5. Number 5, you're going to be taking the rule from a picture. So when you're doing these ones, you want to find a side that you can, 2 sides that you can find the length of. So in the example here, how long is VW? What's that length? It's 3 units. What's V prime T prime? Or is it a T? I can't tell what letter that is. This letter down here and this letter up here. VT, I think. Is it an N?
That's N.
Okay, mine it's hard to tell. What's the length of that corresponding side? 6. Which one's new? Which one's old? Okay, the bigger one's new, and how you can tell is because it'll have that little prime mark. The prime is your new figure. Okay, so 6 over 3 means our scale factor was 2. So when we go to write the rule, we're going to put our scale factor times x and our scale factor times y. So when you guys are doing 5, 6, and 7, you're going to be reading lengths off of a picture to figure out your scale factor, and then to write the rule with it. Okay? Flip it over to 8, 9, 10, and 11. 8, 9, 10, and 11 are the same as 1 through 4, just without having to draw the picture. You're just finding the ordered pairs. So if we're going to if we're dilating by 2 here, what would our new W be? -4, -2. What would the new E be? -4, 2. So you're doing the same thing, you just don't have to draw the picture with it, you're just doing the mapping. And then 12 to 14, you're just, without the picture, trying to find the rule based on the ordered pairs. So if we look at 12, what did we have to multiply by to get from S to S prime? 3. So you could take -12 divided by -4, you get 3. Or you could do -3 divided by -1, you get 3. So you can tell, pick points that are easy for you to divide. So here we went up by 3, so what would our rule be? 3x, 3y. So on ones like 13, if you're not good with decimals, try to find a pair of whole numbers that you can compare. That way you have something that's a little bit easier to do. So that's what 12 to 14 and 8 through 10, you're doing the same thing just without having to draw the picture with it, you're just doing the mapping.